Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over the periodic table of elements. So let's get into this. So the first thing I want to talk about is the symbols and names of the elements themselves. So here we have a periodic table, and so the one thing I want to mention is that the symbol of an element is only going to have either one letter or two letters. Now, I'll talk about these in a moment here, where they have three letters, but they're special. So they're going to have one letter or two letters, and the first letter is always capitalized. And the second letter is always, if there is a second letter, that letter is always going to be the smaller case letter. So, for example, here you have carbon. You can't read the names here, they're pretty small, but here we have C. That's going to be the symbol for carbon. It's the first letter of the name carbon. Here we have nitrogen, it's a capital letter. And again, that's the first letter in the word in the name nitrogen. Here we have nickel, right? So this is Ni for nickel. So the first letter is capital N and the second letter is a small I. So that's different from here. So we can distinguish between nitrogen, that's just one capital N, and nickel, that is just, it's a Ni, capital N, small I. Now, one of the things about symbols and names that you'll run across pretty early on when you start studying the periodic table is you'll notice that the symbols don't make sense with regard to the name, right? So, for example, you'll have, uh, let's see, silver. Silver is Ag, right? Silver, you would think, okay, it's Si, right? But Si is actually silicon. Where's silicon here? I know silicon's here somewhere. Here it is, right here. So here we have silicon. Si is silicon, not silver, but Ag is silver. Or you have gold, which is Au, right? Gold, Au, where did that come from? And mercury is Hg, right? So that's kind of weird. The reason for that is because you have a lot of these elements come from the Greek or the Latin names, right? So, for example, Fe is iron. Well, how did they get Fe from iron? Why not Ir, right? But Ir is down here. That's iridium, right? So, iron, the Fe comes from the Latin word for iron, which is ferrum, right? So, Ferrum, right? So, Fe comes from the Latin here for iron, and so do silver and gold and other elements, right? The other thing I want to point out with regard to the naming or the symbols is usually the symbols will be the first letter of the name, or it's going to be the first and second letter of the name. Sometimes it's going to be the first and third letter of the name, right? So, for example, here we have manganese, Mn, Ma, manganese. So manganese starts with an M and an A, but it's not M, big M small a, it's just big M small n. And so the third letter in manganese is as an N. Same thing with magnesium. Again, Mag for magnesium, but it has a capital M and a G, a small g. So sometimes it's going to be the first letter of the name and then the third letter of the name. But a lot of times it's either the first letter of the name by itself or it's the first and second letter. The other thing you'll notice is that not only is it use a Latin name of not only does a symbol come from the Latin name or the Greek name of the element. But a lot of times you'll notice that these elements are named after famous scientists or places or things like that. So you'll see here that EU is europium, so named after Europe. Here we have BH is borium, named after the famous scientist Niels Bohr. Um, Others that are here, for example, where's the one I was looking for? There's one called Prometheum, right after the Greek god Prometheus, um, and so on. So a lot of these names come either from place names or famous scientist names or things like that. So it all depends on uh, who decides to name them and how they come to that decision. So that's a little bit on the symbols of the periodic table. Um, so let's talk a little bit about the numbers on the periodic table. So here, the main thing you're going to learn about the periodic table is how it's structured. And part of the structure is the numbering of what we call families or groups and periods. And so you might want to have your own periodic table out. If you have your own periodic table out, you can kind of mark it up and label it as I'm going along in this video. So the first thing you'll notice is, I don't know if you can see it here, but there's these numbers 1, 2, 3, 4 on the top here of the columns. And so these columns are called groups, right? So here, I'll write it up here. So columns, those we call groups or families. So groups or families, these are the columns. And each of the groups or families has a number. And you can see here that it's numbered 1 through 18, right? So 1, 2, 3, 4, 5, 6, 7, and all the way to 18. That is one way to number the groups or families. There's another way, which is called the A groups, right? So you can number, and I'll just write the numbers here. So instead of 1 here, we could have 1A. And here we would have 2A, right? And then we would skip over these. These are referred to as the B groups, right? So these are going to be the B groups here, right? And these would be labeled 1B, 2B, 3B, 4B, and so on. They've got a little bit of a weird numbering system here that I'm not going to go over, but basically it's B1, 1B, 2B, 3B. So these are numbered B. So 1 through 10, and they're going to have a B. And then instead of 13 here, this would be 3A, 4A, 5A, 6A, 7A, and 8A. Okay. Oops. So the 8A is not in the screen. How about, is this in the screen? No, that's not. Oh, that's it there. So this would be, let me put it down here. We'll put 8A there, right? So this periodic table is divided into the A groups and the B groups, right? And so there's, again, two different names, two ways of numbering the groups or families. So you can either number them 1 through 18 all the way down, or you could divide it between A and B. So the A groups would be 1A, 2A, and then skip over these, and then 3A, 4A, 5A, all the way to 8A. And so that's the second way of numbering. And there's purpose for either one. One is used in some contexts, the other is used in other contexts. The one that we'll be using most often for beginner level or for your first semesters or a general chemistry is going to be your A and B groups. Okay. And so that's the numbering system. Also, I want to point out here that your rows here are also numbered. And what we call the rows, we call them periods. So the rows on the periodic table is referred to as a period. And the reason it's called a period is because there is a periodic pattern in the periodic table. So there, as you go across, you certain things or certain characteristics of the elements repeat themselves, right? They regularly repeat. So that means that elements in the same groups are going to have similar characteristics. So that's going to be, you see this repeating pattern. And so because you see this repeating pattern in the periodic table, we call them periods. Think of the swinging pendulum. It's also called when the pendulum swings from one end to the other end and then comes back. That's called the period of the swing, right? And the reason it's called a period is because it's a regular pattern, right? So it swings this way, swings back, swings this way, swings back. So it regularly repeats. So you see that in the periodic table, that you see this regular repeating pattern in the periodic table. And so I'm just mentioning, I'm not going to go over any of those right now. That'll be covered in future videos or another video that I have. But that's why I just want to go over, that's why we call them periods. So here, I don't know if you can see the numbers, but here this would be period one. Period one only has two elements in it. So hydrogen and then helium, right? So that's period one of the periodic table. And then you have period two of the periodic table. So this one has 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. And then period 3, 1, 2, 3, 4, 5, 6, 7, 8. This has 8 elements in it as well, and so on. So you got period 4, period 5, period 6, and period 7. Again, you can label your own periodic table this way if it's not already labeled. Okay, so that's your periods and your families or groups. Now, let's talk about names of particular parts of the periodic table. Certain groups have certain names. And again, so you can label this as I go along. So this group here, group 1A, that has a special name called the alkali metals. So here, maybe I'll use a different code. So this group here is referred to, or I should make it clearer. Here, let me get my okay. So this group or family, that's referred to as, as the alkali metals. Hopefully you can read that well. Alkali metals. Now, this family here, this group is referred to as a similar name called the alkaline earth metals. So let me draw. So this is called the alkaline earth metals. Alkaline earth metals. These elements here, all of these groups here, the B groups, they go by the name transition metals. Sometimes transition elements. So transition metals, transition elements. And they're in the middle here between these groups here. And this set of groups here, so these two groups here and these 6 groups here are commonly known as the main group or representative elements. So the main group elements or representative elements. So I can maybe put it down here. So these are main group. So main group and these as well. main group, also referred to as representative elements. So main group elements or representative elements are interchangeable for those. So we have the transition metals or elements, and here we have the main group elements. Okay. Now, keeping with the naming of particular groups, we have here, so group 7A, here, group 7A, those are referred to as the halogens. So let me draw an arrow. So these are referred to as halogens. So there's your halogens. And this group here, group number 8A, this is referred to as your noble gases. So noble gases. So noble gases. That includes helium as well. Didn't mean to leave helium out. So helium, neon, argon, krypton, xenon, radon, all of these are the noble gases. So those are the four. So we have alkali metals, group 1, group 2A, alkaline earth metals, group 7A, halogens, group 8A, noble gases. Okay, so far so good. What about these down here? These are actually inserted here, right? So lanthanum, actinium are in here, and then this comes along. So basically what you're doing is you would split apart all of this and insert these in the middle here. And so we call these, for that reason, the inner transition elements. The inner transition elements. Okay. A few more things I want to point out. Another thing as far as grouping goes is the metals, nonmetals, and metalloids. So first thing, I don't know if it's clear on here, but you can kind of see a red stairway line here, right? So maybe I can make that a little bit better. So if I do this, maybe that will make it come out more clearly. So this here is the stairway basically divides metals and nonmetals. So everything on this side are metals, and everything on this side are nonmetals, right? And these are going to have different properties. Metals and nonmetals have different properties. So metals, for example, are going to be shiny. They're going to be malleable, ductile, meaning malleable means that it can be pounded into shape. You can take a hammer to it and pound it into different shapes. Ductile means that it can be drawn or pulled into wires, things like that. And they're highly conductive, right? So they conduct electricity and heat. Non-metals are the opposite, right? They're not shiny. They're dull. They're not malleable. Like you hit them with a hammer, they're going to break into pieces. They're more brittle, right? They're not good conductors, right? Those are the differences between metals and non-metals. And you can tell that something is a metal on the periodic table here by the fact that a lot of times they'll be in black color. So if they're in black color, then that means that they are solid at room temperature, right? Over here, you'll notice that there's things that are red. Like if it's red, then that's going to be a gas at room temperature. So helium is a gas, nitrogen, oxygen, fluorine, these are gases at room temperature. If it's blue, and that might be hard to tell, so here we have bromine, right? Bromine is a liquid, so that's blue. This is black. This is going to be a solid at room temperature. Bromine is going to be a liquid. Mercury here is a liquid at room temperature, right? It's the only liquid metal that we know of, and that's how it's labeled here in the periodic table. So that you can know, if you know what the colors mean, you can know whether it's a solid, liquid, or gas. So again, here we have the nonmetals. These tend to be liquids and gases. Over here, we do have some solids, right? Sulfur is a solid, phosphorus is a solid, carbon is a solid, right? Um, and over here we have the metals, right? And this is included in the metals as well. Sometimes they're intertransition metals. That's sometimes what they're called. Um, and so the table is divided into those two parts. But there's a third part called the metalloids or the semi-metals, right? And metalloid, you can kind of remember what metalloid means, like if you think of something that's humanoid, right? You have humans and then you have non-humans, right? But then something that's humanoid, that refers to something that's human-like, right? It has certain characteristics of humans and not of humans, right? So the same thing with metalloids, right? So metalloids are substances that have characteristics of metals and characteristics of nonmetals, right? So that's those elements, the metalloids or semi-metals, are going to be on the stairs, right? And most of them are sandwiched between two lines of the stairs, right? So, for example, that would be boron, right? It's sandwiched here. Aluminum is an exception. It is a metal. We know aluminum is a metal, so that's not a metalloid. But silicon is a metalloid. It's sandwiched here. Germanium is sandwiched or surrounded, I guess, by two ends of the stairs here. We have arsenic, and then we have tellurium, we have antimony, and then we have that one. So those are going to be your metalloids. So notice they're on the stairway here. So because they're on the stairway, they're basically on the cusp of both metals, nonmetals, and metals, right? So you would expect them to have properties of both, right? So that's why we call them metalloids. And these are going to be somewhat shiny. They're going to conduct electricity. They're going to conduct heat and things like that. So they're going to have properties of metals, but they're also going to have properties of non-metals as well. So the other thing special about these is these guys tend to be the semiconductors. These are the elements from which we get the semiconductors. Silicon is a semiconductor used in computers, right? So this is very important for our computers and computer chips and things like that. That's why we refer to where we get our electronics and stuff, Silicon Valley, right? So this is the region of the metalloids or semi-metals, right? So we have the semi-metals, metalloids, we have the non-metals, and we have the metals here. So you can see that by far, most of the periodic table is metals. Okay. One more thing. Let's see if there's another thing. I think that's it for this video. I hope you enjoyed this video. I hope this was insightful. If you learned something from this video, then by all means, please like this video. Hit that like button over here somewhere. And also make sure you subscribe to my channel. Hit that notification bell up here somewhere, maybe over here. And when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.